Today's lesson, we're going to look at the reactions of acids and other different types of bases. But first, let's review the acids. These are the important acids you need to know. So H2SO4, sulfuric acid, hydrochloric acid, and nitric acid are your strong acids, and ethanoic acid is your weak acid. That'll come later in the organic course. The key thing is that you know what a salt is. Extremely important. So what is a salt? A salt is a compound formed when the hydrogen ion in the acid is displaced by a metal ion. Let's go back one. Okay, so let's have a look. H2SO4. If you replace this with a metal, you have a salt, e.g. magnesium sulfate. Replace this with a metal, e.g. iron chloride. Replace this with a metal, sodium nitrate. That's what a salt is. A salt is not going to end on oxide, carbonate, or hydroxide. Those are called bases, not salts. Salts come from acids. So you just have to remove the H from the formula of the acid, and you will have a salt. So sulfuric acid will form sulfate salts because of the oxygen. Nitric acid will form nitrate salts, and hydrochloric acid will form chloride salts. Now, the common alkalis are the hydroxides. They're the strong alkalis. So sodium hydroxide, potassium hydroxide, calcium hydroxide. Ammonia is actually a weak base. You don't need to worry about it too much being weak. The other common bases are the carbonates, so metal oxides and metal carbonates. So what we need to look at is the products of these reactions. So I'm actually going to use a different sheet to show you this. Here, and go over a few examples for you, because these equations are very important. So if I do this, then what I'll do is run through some of these questions. All the answers actually are provided on the answer sheet, so I don't need to save this annotation. I can just go through it. So the first one is metal plus acid. We've been over this. It forms salt plus hydrogen. Now, these three or these four are all neutralizations because these are bases. Okay, so these are all neutralizations. This was actually redox, if you remember the lesson before, metal plus acid. So this one here will form a salt plus water because that's what neutralization does. And this one is actually the same as well. It forms a salt plus water. The metal carbonate one, because of the carbonate, also forms carbon dioxide. So you form salt plus water plus carbon dioxide. And the ammonia plus acid only makes a salt, an ammonium salt. So for example, ammonium chloride, ammonium sulfate, ammonium nitrate. So you need to be able to put your hand like this and know these things by heart in order to apply them. And then it becomes quite easy. So in the first part, we need to complete what salt is formed. So if sodium carbonate reacts with nitric acid, it's going to form sodium nitrate. This one will form magnesium nitrate. And so on. This one will form ammonium nitrate. Now with hydrochloric acid, instead of sodium nitrate, it'll be sodium chloride. And this one will be sodium sulfate. Sulfate can be spelled with a PH or an F. So all in all, you should be able to fill this table quite easily. For example, this will be copper chloride. These are just the salts that are formed when the hydrogen ion is replaced by a metal ion. Now in part B, we actually have to write some products. So I'm just going to go over about 4 examples. You need to recognize firstly what is reacting. So the first one is metal plus acid. So it makes salt plus hydrogen. Iron chloride plus hydrogen. Don't say stuff like iron hydrochloride or stuff like that. It's just wrong. Here we have an acid plus a metal carbonate. So I know I need carbon dioxide gas. So the salt is going to be copper chloride plus carbon dioxide plus water. And I will do one more, this one. The salt will be calcium nitrate from the nitric acid, and it is a metal oxide plus acid, so it will just form water with no gases. You should also be able to work backwards. So this one, because it has the CO2, I know it used to be a carbonate, and because it has zinc, it must have been zinc carbonate. And because it's sulfate, it must have been sulfuric acid. So that's how you work backwards. So you should go through this sheet trying to work out each answer. And to challenge yourself, you would try and turn them into chemical equations using the ionic formulae that you've learned from the bonding and using your balancing of equations. So really take your time to practice through these. That's the important thing. There'll be another worksheet attached and you can practice doing your answers to that. So take your time with it. It is quite important. Now, I'm covering all the stuff that's relevant to both specifications in this because Edexcel do a little bit more on the salt preparations and solubility rules. So I'm just doing the basics now. So the next thing is neutralization. So just having a look here. Hydrochloric acid plus sodium hydroxide forms sodium chloride, that white thing that you see, plus water. So we have HCl and NaOH forming NaCl and water. And the ionic equation looks like the one that I showed you in the previous lesson. H plus OH minus makes H2O. Those are the key ions. The Na plus ions are spectator ions and get cancelled on each side. So remember, an acid is a proton donor, and an alkali or a base are proton acceptors. So that's why I've got H plus and OH minus reacting. Okay. Now, let's go to this. What we need to do is describe an experiment, prepare pure dry soluble salt from an insoluble reactant. This is present in both of your syllabi. So, 1 second. So this is called the excess base method and is extremely important because it comes up as even a 6-mark question. Okay, so let's have a look at how it works. We're going to use an actual example for this. So here they've made copper chloride crystals. So let's stick to that. How to form copper chloride crystals. So first of all, you need copper oxide or copper carbonate, and you need hydrochloric acid if you're making chloride salts. So in the question, you'll have to look at what salt they want to form. I would always pick a metal oxide version. So if you're making magnesium nitrate, you would pick magnesium oxide and nitric acid. If you're making lead sulfate, you would pick lead oxide and sulfuric acid. So always pick the oxide. Don't just pick the metal. Okay, in this case, it won't even work because the metal is less reactive than hydrogen. You could pick the carbonate, but you'll be a bit messy because you get loads of fizzing. With this one, you don't get fizzing. So let's look at the method. Firstly, you gently heat up your acid to speed up the rate of the reaction. Then you take it off the heat and add the solid, the copper oxide, slowly stirring with a glass rod until it is in excess. It has to be in excess because you will see it remaining on the bottom. That means it's no longer reacting. If it's a carbonate, it'll no longer fizz. Why do you add it in excess? You add it in excess to ensure all the acid reacts. Because if you add the solid in excess, it's easy to filter it after. If the acid was in excess, it will not be filtered because it'll pass through the filter paper. So you heat, add the copper oxide in excess. Make sure you use the word excess. It'll be in bold and mark schemes. Then you filter out your excess copper oxide and you're left with the filtrate. Now the filtrate will just be copper chloride plus water. So then you just have to get the water out. Ideally, you should put it into not a conical flask, but an evaporating dish. And you would then heat it up gently until crystals start to form on the edges of your evaporating basin. Okay. You could test this by dipping a glass rod and taking it out and seeing if crystals are forming when it cools down. So let heat, don't ever say boil until all the water evaporates. You would say boil gently until half the water boils and crystallization is reached. You could even use a water bath to heat it instead of doing it directly. Then you leave your solution to cool and crystallize. That will allow large crystals to form. As it cools down, solubility is decreased. That's why the crystals come out. Then you would either filter them out again and pat them dry with a filter paper, or if you have more time, you could leave it in a drying oven or windowsill for the rest of the water to evaporate, and then pat dry your crystals. Okay, but depending on the question, you might want to just filter out the remaining water after the crystals formed, since you don't have 2 or 3 days. So this is the method used. You need to learn it very, very well, because it gets tested a lot. So the important points being that the metal oxide has to be in excess to react all the acid. And the important point is you don't boil all the water off. You boil approximately half the water off gently until crystallization is reached. Then you leave to cool and crystallize. Right, that completes the basic part of this. If you're an Edexcel student, you will need to tune in for an extra practical on this, and also on the solubility rules. Just came to my mind, there's actually one more practical that you both need to know. And there's this one here. So just this one is very brief explanation because it's the same as the titration. But for both Edexcel and AQA, you need to know how to make a soluble salt from soluble starting materials. So this one was to prepare a soluble salt from insoluble reactant, i.e. the metal oxide. What happens if you have 2 soluble ones? Then what you do is you actually do a titration like before. So I'm not going to go over all the steps again. But by doing the titration, you know exactly how much acid and alkali was needed for the neutralization. So then you would repeat the whole titration again, but with no indicator, because otherwise the indicator would contaminate your crystals. So say you know it's 25.30. You repeat the titration, but don't put any drops of indicator, and just open the tap and add exactly 25.3. Then when they've mixed, they would have mixed in the perfect ratio. So that means they would have achieved, for example, just sodium chloride and water, which then becomes the same as the experiment here. You've just got a soluble salt in water. So you do the crystallization technique, which is when you boil half the water off gently until crystals start to form on the edge. Then you leave it to cool and crystallize. Then you filter out the remaining water. So really, it becomes the same as the titration method and the same as the crystallization technique. There's only one different step, which is where you add the known volumes of acid and alkali together with no indicator, so it doesn't contaminate it. So that's why it's so imperative that you learn the titration technique and the crystallization technique. Okay, that's the end of this lesson. If you're Edexcel, join me for one more lesson on preparing an insoluble salt.